we need to generate parentheses. So given 3, so we have 3, we need to generate 3 different parentheses, and all of them should be valid ones. So when it's 1, then the output is just 1. The way we're going to solve this is just with backtracking, then will be a DFS recursive call. So let's start solving it. So basically, when we are forming this one, the key is like in order to generate parentheses, we need to have the left side of it and right side of it, and then when they are just together, then it's a valid parenthesis. So we need to keep track of the left side and right side, and for each left side we have the equal amount for the right side as well. So if you take a look, we have 3 of this, and then we have 3 of this, and for each of them it's the same way. The way it is going to be, we will generate a tree. So left side, left side, left side, then we'll go right side, right side, right side, then underneath we will backtrack it up until the point where we can switch it to something else, then we'll do the same thing again, then we'll backtrack it again, and then it's like do it again. So we will have a tree. So let's solve this. New array list. We'll call our backtrack method in here. We'll need to send our result. We'll need to send a string builder where it will be getting us the current combinations of them, and we need to count the left side of it and right side of this parenthesis, and we need to send also n. So in the end, we'll just return result from here. Now let's work on our helper method. So backtrack, send this list of string, which is our result. Then we have our string builder current, which will be getting all this option numbers of parentheses on the combinations of them, and then this is the left side to count the left parentheses, right to count the right parentheses, and our n. So this will be backtrack is TFS, so it's a recursion. We need to define our base case. So when this left will be equal to n, and also right equals to n, meaning if you take a look, left side is 3 equals to 3, right side is 3 equals to 3. So then we will add to our result, add this given current, which is a string builder. So we need to update it to string, then we can just return from here. And the other part is if our left parenthesis is smaller than n, so left where we are counting this one, we will add it to our current. So append, and we'll call our backtrack method our recursion. So result current. So left now will be incremented because like we'll be moving one by one, and the right stays the same. Then we go to again, yes. Then we will do the backtracking of it. So we were adding all this 3 right here. Then we'll remove the last one. We'll go with the other option. Then we'll last one. Then we'll go with the other option basically. So for that current, you can say delete char at the last index of it. So length -1, and we should do the same thing for the right side of it. So right smaller than left, current append this side, because right cannot be more than left, and they complement each other. So when parentheses opens up this way, this closes back. So backtrack, we're calling the same thing. Current, now left stays intact, now right gets incremented, and same thing as above, we need to backtrack it. So current length -1. That's about it. So let's run our code.